Assalamu alaikum, Prof.
Alaikum salam wa barakatuh. Good morning.
First of all, thank you, Jazakumullah Khairan, for this presentation. Wallah, it's really been very helpful because I was wondering where I was going to start from. I didn't really know how to go about it. But, you know, with this presentation this morning, you have told me that I can just input my data into the WEKA software and run the program, and then the results will be generated. From there, it's easier to discuss in a group. So I want to thank you for that clarification.
You are welcome. Barakallah fiqh. Thank you very much for that. So hope we benefit also. Thank you. So number 2 is Mr. Richard D. Sorry, Richard D. Yeah.
Yeah, good morning.
Good morning.
I'm doing well.
Yeah.
I've observed that the data was not balanced. One was 200, one was 320.
Okay.
During the previous training, I was in shortly.
Okay.
During I Helmesia. The people. You discuss one method of balancing of the data.
Yeah.
I was having a discussion with a friend who mentioned the Bell approach of also balancing. I think that one is for upward balance, but the previous one you did was for, is it down? It's like balancing it upwards or downwards, depending upon what you want.
Okay.
So is there a way you can show on WEKA how that balancing can be done? And 2, the second question is, how can you do the hyperparameter optimization? I realized you were selecting it there. You select 1, 3, 5, and then later on the data will be plotted maybe on Excel. Is there a way of automating it in WEKA so that you say that it should select 1, 3, this, and the rest?
Okay. So thank you very much for the questioner. So also for the first questioner, it is clear. Like I said, the essence was to get everybody to be practicing and try to work on this system. And I wish you all the best. And to Mr. Richard's question, yeah. Number 1, regarding the optimization, regarding the imbalancing. Yeah, you can see the imbalance here. When you click on class, you can see clearly here. You see, this one is 320 positive, and then negative is 200. So it's a special data set. Usually, the positive are usually lesser than the negative, because in a population, in a normal population, we expect minority to be sick and majority to be okay. But this kind of data set now, majority seems to be sick and minority is okay. So which is a very strange data set, but it's possible. And I think it was due to the way the data set was collected. It was collected from a medical center. So people who came for medical follow-up, they were interviewing them. So maybe majority of those people are actually their diabetes because they actually came to the clinic, and then they had the control experiment for the other one. Yeah, for this kind of case, the starting point is to first of all try to run the experiment as it is. Yeah, and then the next thing is, are you doing fine? Let the data speak. Let us see what you can get with the original data. Then the next is to now move forward as, okay, I've done what I can do, including hyperparameter, because I always encourage people, don't go into balancing data before you have explored the natural data. Let the original data speak with you. Because I've seen a situation whereby even though there is data imbalance, there was almost 100% accuracy. Everything was done. The system was still able to recognize both classes. Now, and for having 200 to 320, though it's imbalanced, but the degree of imbalance is not that very huge, a good system should be able to track it. And you can see that even the simple k-nearest neighbor was able to achieve 95%, only 5 mistakes out of data of 520. That is excellent achievement, even though we didn't do any balancing. So sometimes without balancing, we can get excellent result. However, it is when the balancing is, the imbalance is so huge. Imagine we have like 2,000 samples for one case, and the second class is like just 100 against 2,000. You can see, I mean, when the range is really very wide, then we tend to be very concerned. Even at that, it is good to run the experiment and see what result you can get using the original data set. So this is the first point. So moving further, once it is established that, okay, there is imbalance, we have the undersampling and the oversampling. Undersampling means, which is the one I prefer, because we don't want to introduce fake data. So in that sense, we want to reduce this 320 to become 200. You see? So randomly remove some data set. There are several methods, like you just mentioned, so many methods. People are coming up with methods, especially when people face, by the way, data imbalance is a research on its own. I've seen someone that was a friend of all who did PhD in data imbalance. You see, his own PhD was on data imbalance treatment. And he came up with so many methods you can use for imbalancing. So there's so many work in this area. So depending on the problem you're having and how serious that imbalance is. But the very popular one is the smooth that we also mentioned as it's often used, but it doesn't mean that it's going to work in all situations. So that is why it's always good to give it opportunity to try different methods of data imbalancing. However, you can also start with a very simple one, manually just remove the excess data from it and then do it. However, that could raise some issue, but if you can do it randomly, it is good. Otherwise, we can go to, I think one of the pre-processing methods we can use if WEKA is data imbalance. And what we are going to do, maybe because of our time, we are going to kind of, I will note it down, maybe data imbalance will be one of the topics we are going to treat in one of these days. And I will look at some of the facility or platform that we can do, a data balance method demonstration for us. Either we want to use the smooth or one or two other methods that we can demonstrate, so that whenever you have data imbalance, we can quickly use such methods. But however, I want you to know that there are so many methods of data imbalance, and no one can categorically say that this is the best. So, and that is why if the data can still perform without imbalance, we do it to be able to understand naturally, let the data speak, to see the performance of the data. Then we move on to try to do the imbalance. And my preferred method is to reduce the sample so that we don't create fake data. But sometimes also oversampling is also part of the data imbalance system that we might have. As for the second question regarding the hyperparameter setting, yeah, when you want to set the parameter, we did the simple one. I like to start with this one with newcomers so that everybody can demonstrate it easily. So once you open, you select and when you select a particular algorithm here, you can see the hyperparameter. The one listed here, they are the hyperparameter, the K and the distance measure. Okay, you can see the distance measure, Euclidean distance. These are the two hyperparameters. Even though there are so many parameters here. So somebody asked me, how do I know there are so many parameters here? How do I know which one to ignore and which one to do? I said, you go back to this part you can see here, K, and then the second one is this Euclidean distance. Others are just there as normal parameter. The hyperparameter are those that will affect the algorithm, as the case may be. Now, so we selected 1, 3, 4, and the likes. So if you want to automate it, yeah, instead you don't want to plot it as the case, we want to do it manually. Yeah, okay, what you do is you go to experimenter in WEKA, and I think that was one of our video earlier that we demonstrated this. You go to WEKA, you go to experimenter, you don't go to Explorer. We were inside Explorer before. Click this experimenter, See, the experimenter will give you the opportunity. What does he do there? You can set up several k-nearest neighbor inside the experimenter. You can set it up for when k is 1, when k is 2, when k is 3, sorry, when k is 3, when k is 5. You set everything up, and then once you set it up, you can click run and you can go to sleep. Tomorrow you come back and see your result in the Excel file. And then you can start selecting it and plotting your results. So this is where you can actually make use of a experimental WEKA. You don't want to do it manually one after the other because of time or whatever reason. So even though for the first comma, I advise them to do it manually, but once you are comfortable with it, then you can set it up in WEKA, experimenter. So whereby the beginning also is to open the file you want to use and try to, once you open the file, you can start setting up the algorithm, then set it up when k is 1, set it up when k is 3, k is 5, k. It's like you are running multiple experiments. You can set up as many as possible. Then you are also set up for Manhattan distance and different distance measure. And then you click at once, and then it will run as a batch, and it will put the result into an Excel file for you to view. So I want to believe we already had a video on this particular topic on how to run multiple hyperparameter search in experimenter in WEKA. So someone can help us point to that particular video for the reference of all because of our time. So I hope I answered those questions. So thank you.
Thank you very much.
Yeah, you're welcome. No. So Mr. Olayinka Yusuf.
Okay, thank you very much, Prof. Assalamu alaikum. Yeah, once again, I want to commend you for the good work you are doing. We are really enjoying it. To pray that Allah subhanahu wa ta'ala will continue to strengthen you and grant you wisdom and knowledge. Yeah, I have two questions.
Okay.
One has to do with the hyperparameter tuning we talked about. There are basically two hyperparameters with the KNN, the number of Ks and then the distances. So I saw that in the manual one that you did, you first picked 1, then 3, then 5, then 7, and we observed the trend in the performance. Yeah. So before we now went to the distances. So I was thinking, what difference will it make if I picked under the equilibrium distance, if I picked 1, 3, 5, 7, and so on, then I pick maybe Manhattan, for instance, and I pick 1, 3, 5, 7. You know, this will be different from me trying all the different Ks at a go. Then after that, I saw the best K. Then after the best K, I now settled for different distances with the best K alone. Yeah. I think that would be different from me. Okay, when K is 1, what will all the different distances give me? Yeah. And when K is 3, what will all these distances give me? So basically, that would be more laborious, so to say. But I want to ask, would there be any significant difference in the output? Can I answer ask the second question with this, or I get an answer for this first?
Okay. Okay, you can go ahead. I get your question. Okay. Answer it. Go ahead with the second question.
So the second question emanated from your response to Mr. Richard, the last questioner. When you are talking about the kind of, where you got the data, when he was talking about the imbalancing. So, and you hear that maybe because data were collected from an hospital, so those that were sick were more than those that were, that were okay. And so it just occurred to me, could the kind of data used for an experiment affect the modeling, the output? Okay, you did mention that in the real world, one would expect those that are healthy to be more than those that are sick. But in this case now, because data were collected from an hospital, so to say, then we realize that there are more sick people than healthy people. And then this data has been run, and we have seen the performance. So I was now thinking, what would have been the case if there were more healthy people in that data set than the sick one? Then could the prediction in both instances be significantly different? Okay. And can that affect the modeling?
Okay.
Those are my questions, sir.
Thank you very much. Starting with your first question, which is the issue of hyperparameter optimization. You see, the issue of hyperparameter optimization is also a very big issue. It's a wide issue with different options. Now, I like to start with something simple. This is the principle of machine learning. Start with something simple, especially with the knowledge of how hyperparameter works. For example, if you are working with support vector machine, so I will tell you, first of all, search for the kernel value. Once you get the best kernel function to use, either polynomial or Gaussian, the other parameter is C. If you can also search for C, then other parameters are they are very infinitesimal performance improvement on the system. But this is based on experience. You get the point now, and the understanding of the theory of such algorithm. However, to be on the safer side, yeah, it's good to do the one you have just mentioned. Yeah, though it's going to look laborious. Yeah, but then, as they used to say, when you want to hit the onion that is inside the rock, you don't look at the axe. You have to struggle and do as much as you can to be able to get the onion out. So sometimes, yeah, it takes a lot of time, but you need to do that's why the exhaustive search method is always the best, even when you are doing feature selection. But it's not practical. You see, that's why we go for different algorithms. Okay, we use this idea. No algorithm will guarantee for you that you are not missing the local minima or the local maxima. You know, when you are searching for a value, anything that involves searching for the best value, then this is an optimization problem. Sometimes you get stuck in the local minimum or the local maximum, depending on the kind of problem you are solving. Is it minimization or maximization of problem you are solving? So in this case, the best bet is the exhaustive file as a search, like you have said. Pick Manhattan, search for 1, 2, 3 up to the end. Pick a shape equation, search for from 1 to the end. This is like doing grid search now. For every distance measure, we exhaust all the 1 and 2, 3, 4. This is the best you can go for. But then, as you say, the time is the issue. But if somebody can do it, it's excellent. For those doing programming, you can write a program and do exhaustive search, but it's going to take time. And also, you can use experimental setup to do that. Like the one I mentioned in WEKA, I think we already have a video for that on how to do experimental setup. Set up the experiment for when it is one distance measure, and for that distance measure, you have 1. The same distance measure, you have 2. Another distance, the same distance measure, you keep creating them. Let's say we want to test from 1 to 15. It means for Manhattan, you are going to have 15 experiment setup. For shape equation, you are going to have another 15. For the other one, Manhattan, you are going to have another 15. For every, so you are going to see the number of 15 times the number of distance measure. That's going to be like maybe 15 times 5 experiment. So you're going to set up all these experimenter in WEKA, and then you just click run, and then you can go to your bed and sleep. Tomorrow morning, you come back and you see your result in Excel. Then you can now analyze the Excel and plot it and see which of the combinations is giving me better result. So this is workable in K-nearest neighbor because it has very few hyperparameter, K and the distance measure. Imagine you are working with something with another algorithm that has like 6 or 7 hyperparameter. That's going to be 15 times 7, and you are not even sure that you get. We are just assuming that you are going to get the best from 1 to 15. What if you? Hello?
Yeah, I'm getting it.
Yeah. What if you don't get the best result between 1 and 15?
From 15, 1 to 15.
Yeah. After you get the result in Excel, you now found out that all the best results, they are under 15. You see, the best result are under 15. It means you need to search for 16, 17 again because the best results are occurring under 15. It means I need to expand that number. Then you have to set up another one again, starting from 15 to maybe 25. Until you see that the result goes down, then you can now say, okay, I've gotten the best. So this is what we call hyperparameter search, and there are so many methods in it. And that's because of the exhaustive search might not be practical. If there's no time, then people go for different optimization like genetic algorithms. Even though with that, nothing can guarantee that you cannot miss it because it's a natural law. Sometimes it gets stuck in local maximum or local minimum, depending on the problem we are solving. So we start from the simple. Then if you can do exhaustive search, like you described, it's excellent. And it's also part of the method for searching for optimization strategy. But from my experience, once you get the number of K, those Manhattan and the like, sometimes they don't have enough effect, but then it's dangerous to make that assumption. Sometimes your data might prove me wrong because of the principle of let the data speak. So yeah. The last question that was regarding the issue of imbalanced data, that is it going to affect? For sure, the data we get will affect the modeling. So that is why it is good to always have data set that is nearly balanced. Even though then it also depends on even the one that we say nearly balanced, because sometimes you see people that participated in that particular kind of interview. Some of them are not sick, but they are about getting sick, you know? So they are going to affect the data. You label them as negative, although they are getting closer to being sick, or maybe they are missing something. You are labeling them negative, but they are actually positive already. They are going to affect your modeling. A lot of them can affect your modeling. This is why recently we tried to make a kind of proposal that, okay, when we have a data set that they told us that this data is positive and negative, sometimes we need to do clustering to really check, are these two classes? Because sometimes you find out that when you do clustering on the data is actually having three classes. It means some to class 1, some to class 2. There are some that are neither here nor there. But the labeling of the data already classified them as 2. This will affect our model. So the idea is we try to take away those that are neither here nor there. We remove them from the data. So Mr. Usman.
Assalamu alaikum.
Dr. Usman. Now, alaikum salam.
Mr. Usman. Good day, Doctor. Thank you for your presentation as usual. So actually I have a question. We did the experimental section from the summer classes.
Okay.
And even during that time, I couldn't open the file. When I tried to load the file, I get an error message, couldn't open experiment file.
Okay.
Invalid stream header for one with some numbers. So I wanted maybe if you can just maybe open the file and I see how it loads. I think from there on I can go back and search for the summer classes, and then I will see how you kind of load the experiment. So now I just want the file to kind of be loaded into the experimenter so that I can use it.
Okay, okay. So there you have to, you go to the simple, of course, yeah. So you want to do a new system entirely. You have to see, I'm clicking new, that I'm doing something new. So you need to open the file. First of all, you have to configure the file. Yeah. Then you set up how you want the experiment to be, the number of fold. Are you using train split method, or you want to use cross validation, as the case may be? Yeah. And then it's always good to also, you have to select the classification algorithm you want to use or the data set you want to use, which one comes first, depending on the system you want to actually set up. So set up your result is very important, where the result is going to be kept. Usually we set it up here, remember. Yeah, I have it here. I'll call it WEKA experiment. Yeah. So where you want the result to be kept. So yeah, depending on the kind of, you can create a new one. Yeah. Now, so we are setting up here where you want your result to go to. So now I'll bring in your data. We can. Okay, you can see we couldn't see any data there because we need to. Now. Sorry here. Yeah, this was trying to bring in existing file. Yeah, so we're gonna have the data algorithm of the data first. Yeah, this is the data set. Yeah, sorry, this is where you're going to have the data set. Add the data set from here. So if you are from this WEKA. CSV, so bring in the data. Yeah. So you bring the data is in now, this data you want to use. Now it's time for you to add the experiment you want to set up. You see, let's say we want to set up IBK as the previous questioner mentioned. So you set up your first IBK. Now, so we can see KNN is, these are the two things. Euclidean distance first with K is equal to 1. This is set up. I add another one. Now KNN now is 3. The same, I keep this one constant. It's still the same Euclidean distance. So this is second. So I keep adding them. This is 5. So add as many as you want. Once I am okay, after getting to like maybe this is 7. Maybe okay, I feel it's okay. Then I go add another one again. Here now I'm going to change this to, I'm going to change it to Minkowski now. And I start from 1 again. So keep setting up 3 because it's now Minkowski distance measure. So keep adding them. 5. Also, I'm going to add up to 7, assuming that I'm going to get the best result from 7. So it means I've set up 4 for this. You can also do a case 1, 3, 5, 7, K1, 3, 5, 7. We are using odd number because the number of classes matters. If you are having 2 classes, the neighbor should be odd number because you are going to vote. If 3 neighbors, 1 is sick, the 2 of them are not sick, we have to vote to be able to know where to classify someone. This is how k-nearest neighbor works. So you need to keep adding. Let's say I want to add other ones. So I hope that is clear. So this is, I want to change it again.
Yes, doctor, it's clear now.
Okay.
Since I know I can load the file.
Okay, now
so
this is how you do it. So the first thing you start with, you first of all try to set up where you want the result to go. This is the result location. Then you add your data from here. You have your data, and then you set up the algorithm. Look at how many algorithms we have set up. This is, now we can keep adding as many as you want, and then finally you are going to start. You see, now I started at 10:42, so it continued to run. Finally, depending on how long it's going to take, I will keep checking the location of my file. So in as much as there's no error, we don't have any error now, it's still working. Now it's finished at 10:42. So we go to the file and then we try to see our results as the case may be. Yeah. Yeah, you have the result, which is new. Yeah, this is the result. Save it is new in a, you can open it. You can open this one with Notepad, can open it. Yeah. So you open the result and then try to see what are the output. Yeah, these are the system it has generated for you. So we should have set it to have in Excel. Excel is easier for you to visualize compared to ARTF file. So this is how you visualize the outcome of this is how you visualize the outcome of that. So hope that clarifies.
Yes, doctor, it's clear. Thank you very much.
Barakallahu Feek. So I wish you all the best. I believe that is the last questioner, and that's where we're going to be. Okay, yeah, that's the last questioner. So thank you all for the time, and I wish you all the best. Please, let's put whatever little we've learned to practice. Let's start working on it, start demonstrating it, and yeah, you start from a place, at least you are going to see the benefit and also the outcome of your efforts. So don't wait until you know everything, practicalize it. Like I keep saying, machine learning is better learned through practice. So the more you practice, then the better you become. And it's not something you can memorize on the concept. As you grow in the practice, you keep knowing different concepts actually. So based on your experience. So once again, thank you for the attendance and I wish you all the best. Wassalam.